Hi everyone. So today we will solve this problem. Delete the middle node of a linked list. So we are provided with the head of a linked list and we have to delete the middle node of this linked list and we have to return the modified linked list. So the middle of a linked list of size n is the n by 2th node. Okay. So if we see, there can be two scenarios. Either the size of the linked list can be even or odd. So if it is even, right, in that scenario, if the size is 4, we will simply divide it by 2. That means we will get 2. So we have to delete the second node in the linked list. So if this is the linked list of size 4, so we have to delete the second linked list. That means 0, 1, 3. We have to delete this node. So this number is basically 0 indexed. Okay. If there are 5 nodes, okay, so size of this is 5. So we will do 5 divided by 2, which will be 2.5, but we will take the lower bound. If you see here, we have a lower bound like this. So lower bound of 2.5 is 2, correct? So again, we will delete the second node itself. All right. So let's look at this first example. So here, the size of the node is 7, right? So if we divide 7 by 2, we will get 3.5. We will take the lower bound, which will be 3. So we have to delete the third index. Okay. So third will be 0, 1, 2, 3. This one we have to delete. Okay. So if you see, node 3 with value 7 is the middle node, which is marked as red. So after deletion of this node, this linked list will become like this. 1, 3, 4, 7 got deleted, then 1, then 2, then 6. Okay. So this will be the new modified linked list, which is what we have to return. So let's look at the concept, how we can solve this problem. So we have a linked list and to solve this problem, we will be using fast and slow pointer approach. Okay. So fast pointer and slow pointer, these two pointers will traverse the linked list. The only difference is that fast pointer will move 2 nodes at a time, whereas slow pointer will move 1 node at a time. So let's look at the example. So if we see, we have 3 pointers over here. One is the fast pointer, which is pointing to the first node. Slow pointer is also pointing to the first node right now. And we have this P, which is the previous pointer. So this previous pointer will always be 1 node before the slow pointer. The use of this pointer is for deletion. Okay, because we have to delete the middle node. So this pointer will help us in that process. So first of all, let's look at how this traversal will go. So first of all, we will move the fast pointer, then we will move the slow pointer alternatively. As soon as fast pointer reaches the last node or the null, then we will stop. Okay, so this is what we have to do. So first of all, fast pointer will move and it will jump to this node number 2. Right, as we know, it will move 2 nodes at a time. So we traverse 0 and 1 and we jump to node number 2. Then the slow pointer will move. It will only move by a single node. So it will move here slow. And we know that previous will always be 1 node before the slow pointer. So this P pointer will now be here. But now again the fast pointer will move. It will jump and go to node number 4. Okay. And then slow pointer will move. And then P will move. P will be previous. Okay. Now, if you notice, the slow pointer is pointing to the middle node, right? The length of this linked list is 5. 5 divided by 2, lower bound of 2.5, which is 2. So node number 2 is the middle node. Okay, that means when the fast pointer reaches the last node or the null, the slow pointer will be pointing to the middle node. Okay, why this works? The reason is straightforward. We know that for one fast pointer, like if fast pointer moves 1 time, it is equivalent to 2 times of the slow pointer. right? Because fast pointer is moving two nodes at a time, whereas slow pointer is moving one node at a time. And if we solve this further, we will get slow pointer is equal to fast pointer divided by 2. That means if fast pointer is at the last, so this last will get divided by 2. Last, basically the last node. That means slow pointer will be half the distance from the fast pointer. Now, according to the question, we have to delete the node also. Okay, so we have this previous pointer which will help us do that. So what we have to simply do is now, this previous pointer is here. Okay, so basically we will remove this next node for the index 1, and this node will point to the fourth. Okay, this fourth element. And we will remove this, and at the end we will free this node, the slow pointer node. And this is how we delete the middle. Okay, so let's look at the code. It is pretty straightforward. All right, so this is the code. So we have 3 pointers: fast pointer, slow pointer, and the previous pointer. Previous pointer will help us in deleting the middle node. So first of all of them are pointing to the head, and then we will begin the loop, this traversal loop. So this loop will keep on traversing the linked list until fast is at the end or fast reaches the null. Okay. So first of all, previous will store the slow node, and then fast pointer will move 2 times, and slow pointer will move 1 step at a time. And this loop will keep on traversing the linked list. Once this loop is done, slow will be at the middle. Okay, so on the right hand side, you can see fast is at the last node and the slow is at the middle. And previous will be 1 step behind the slow pointer. So it will be at node number 2. So then what we have to do, this next pointer of 2, this should point to 4 now. Okay. So how to get the address of this 4? We can say slow arrow next. Correct? So we should say previous arrow next should be equals to slow arrow next. This is what we have done. So we have removed this link, and now this link is pointing to node number 4. Okay. Once this is done, we have to check whether slow is at the head. So this scenario will happen when there is a single node. In that case, what will happen? There is a single node. So that node itself will be the middle. Okay. So in that scenario, we will obviously remove that node. So head should point to the null. That means the whole linked list is now deleted because there was only a single element. So once this is done, we will delete this slow, basically the middle node, and then we will return the head. And if we see, we are simply traversing this linked list. So the time complexity will be big of n, where n is the length of this linked list. Okay. So this is it. I will share the link to this code. And thanks for watching the video. Bye.